So now we get to the point in this section where we actually have to sketch the graph. Now it gets a little confusing looking back and forth trying to find all the information that's needed, so that's why I've summarized it here. We're going to look at the most important information that we have. We are increasing this function from -3 to 0 and from 0 to infinity. Increasing again means the function is moving upwards. Function's decreasing from -infinity to -3. No maximum, but we have a minimum at -3, -27. Function's concave up from -infinity to -2, and again from 0 to infinity. Concave down from -2 to 0. Two inflection points, -2, -16, and 0, 0. X-intercept at 0 and -4, Y-intercept at 0, and no asymptotes. So before we go randomly putting points down, dealing with increasing, decreasing, we need to actually look at what scale do we need. So looking at everything that's involved so far, the biggest number that we can see on the y-axis is a 27. The biggest number we're going to have on the x-axis is a -4. So we need to be sure that we can reach those points and use as much of the graph as possible. Now the way that I have this graph set up, I have 10 ticks above, below, left, and right of the origin. So for my scale on the x-axis, I'm going to have 2 ticks being 1. For my scale on the y-axis, I'm going to have each tick being 3. And when you're putting a scale on, all we need are the first couple, and that gives us enough information to tell what the scale is going to be. First thing we need to start by graphing is the actual points themselves. Those would be the minimum, maximum, the inflection points, the intercepts, and the asymptotes. So the minimum, which is at -3, -27, is going to be right there. Inflection point at -2, -16 is going to be about there. Now with the scale that we've chosen, it's a little bit of a guess, but we do the best we can. We also have an inflection point at 0, 0. X-intercept at 0 and -4. When we have the one at 0 already, it overlaps with our inflection point. Second X-intercept at -4. And Y-intercept at 0, which overlaps with the inflection point of the X-intercept. Next thing we need to look at is the increasing and decreasing. That's the most important. So this function is decreasing from -infinity to -3, which means it's moving down from -infinity to -3. What we need to be aware of is that the function is moving down, so it might start up here. As it's moving downwards, it has to continue moving down until it gets to -3. Function's increasing from -3 to 0, so it turns around, moves up. The only thing we need to be aware of is that it does pass through that inflection point at -2, -16, and continues going until it hits that other point, that x-intercept. The function is still increasing from 0 to infinity, so as we leave 0, the function is going to continue moving up. Arrows on the end, we are continuing this function. But now to make this graph look maybe even a little bit better, we can take a look at the concave up and concave down. Concave up looks kind of like a bowl, concave down looks kind of like a hill. So concave up from -infinity to -2. If we take a look from that left side of the graph all the way to that green line, we're trying to make it look like a bowl. And I've done a reasonably good job of that. Again, concavity is tough to tell, but you do the best you can. So then we have a concave down section from -2 to 0. And concave down we want to make look like a hill, and if you look at that, you might believe that that's the left side of a hill. And again, concave up from 0 to infinity, it's going to look like a bowl. So it's not a perfect sketch. We don't have a lot of points to tell us what this function looks like, but we do have enough to tell us the general shape, and that's exactly what we're going for. So this would be a perfectly good sketch of this function.